Okay, welcome to the first video where I'm going to go through homework number one. You guys should have already submitted homework number one, and that's kind of how these homework videos will go. The following week, I will release the homework video. That way, you guys aren't getting the answers before you have to submit it. But my goal with these videos are for you guys to understand the key concepts in general chemistry. You can pass this class with flying colors by straight memorization. However, when you get on to more difficult coursework, or when you have to take a graduate exam, the memorization is going to fail you. Now, there's things that you must memorize in this class, but I also want you guys to understand all the concepts beyond surface level. And so that's what I'm going to do in these videos, and I'm going to pinpoint key things that you need to understand for the exams. Okay? So let's get started. The first question in your homework was choose the placement and charge of a neutron. So for this question, it's relatively straightforward. This is probably just a pure memorization question, but just so you guys can get an understanding, neutron, easiest way to think about it is simply neutral. Okay. So that tells us that the charge is neutral or zero. But we also want to know where neutrons are located. And so the two choices that you were given were outside the nucleus or inside the nucleus. So the thought process is very simple. Neutrons are in the nucleus. However, if you need something to help you memorize that, you can understand that protons and neutrons make up the mass of an atom, and mass is always in the nucleus. Electrons are on the outside, and their mass is negligible. You don't need to worry about their mass. So for this question, we know that a neutron is in the nucleus and it has a relative charge of zero. These are very common exam questions, so make sure you know the characteristics of neutrons, electrons, and protons. They are very, very easy points. Do not get them wrong. Question two, you're provided with a table and you're asked to fill in the blanks. So you have chemical symbol, you have atomic number, mass number, number of protons, and number of neutrons. And so here you really need to understand what each of those headings mean. And so let's just quickly go through those. So obviously the chemical symbol, you're just pulling this straight off the periodic table. Your atomic number, you're going to see this as the largest number on the periodic table, and the atomic number is always associated with the number of protons that an element has. Okay, so this tells you number of protons. This tells you number of protons. Okay, the mass number tells you number of protons plus neutrons. So that number is going to be right under the chemical symbol on the periodic table. Remember I said before, the mass of an atom is always located in the nucleus. So what's in the nucleus? Protons and neutrons. So you have number of protons and number of neutrons as the last two categories. And so once you figure out the two numbers or the two categories in the beginning, so once you figure out the atomic number and the mass number, finding the number of protons and neutrons is very straightforward. So we have this chemical symbol Ca, that's calcium, and it has an atomic number, if you look at your periodic table, of 20. So what does the atomic number tell us? It tells us the number of protons. And so we also know that calcium has 20. Has 20 protons. And we see that our mass number is 40. So if we have 20 protons and the mass number is protons plus neutrons, the number of neutrons that we have would also have to be 20. Now, for the second row, we're not given the chemical symbol or the mass number or the number of protons, but we are given the atomic number. And what does the atomic number tell us? The number of protons. And that is the large number above the elements on the periodic table. And so we just need to find 25 on the periodic table. And we find out that is Mn. So we know how many neutrons it has. We know the atomic number, and we now know the chemical symbol. So we also know the number of protons because the number of protons is equal to the atomic number. So the number of protons should be 25. And we know that the mass number is protons plus neutrons. So we have 25 plus 30, which is 55. Now, these are very simple mathematical equations. On the exam, you're going to have a calculator, so you can speed up the process by just typing these numbers into your calculator. But this is also a very common exam question. Now, again, the exam is multiple choice, so it's going to be slightly easier, but you need to understand each of these headings and where you can find them. So that's question 2. Now, question 3 says, how many protons, neutrons, and electrons are there in an atom of 118, 50 SN? So, truthfully, you don't really need to know by heart what this chemical symbol is, but you need to understand the way in which it's formatted. So, we have this 118 above, and we have 50 on the bottom. Now, intuitively, you can take a guess and say that the 118 is the mass number because the mass number is two things where the atomic number is just protons. But always remember that the mass number will be on top and the atomic number on the bottom. So, what does the atomic number tell us? The atomic number is equal to the number of protons, which means here we have 50 protons. The mass number is equal to protons plus neutrons. So it has to be 118 minus 50, because this is the total. We have 50 protons. We're trying to figure out how many neutrons. So that is equal to 68 neutrons. Lastly, you want to figure out the number of electrons. And this is very, very simple. When you're looking at this format, we see no charge on our chemical symbol. What do I mean by charge? So let's say we had oxygen and we had a -2 charge. This is a chemical symbol that has a charge, meaning there are more electrons than there are protons. Because when the electrons and the protons are balanced, it's 0. So if you had +2 and -2, that is 0. But if you had -4 and +2, that would be -2. And so we have an imbalance of our protons and electrons. But here we see no charge difference. So electrons are equal to the number of protons. So we have 50 electrons. And that is how you should think about questions like these. Now, question 4. An imaginary element on Mars is composed of 3 isotopes. 50.24% of isotope X16 with a mass of 16 AMU, 18.95% of isotope X14 with a mass of 14 AMU, and 30.81% of isotope X17 with a mass of 17 AMU. Calculate the atomic mass of the element. Type in your answer with three significant figures. Do not type AMU in the box. So let's get a little bit more space. So let's just reiterate what we were provided with. So it says that isotope X16 has 50%, 50.244%, and a mass of 16. Okay. Then we have isotope X14, which is 18%, 18.95%, and has a mass of 14. And then we have isotope X17, excuse my handwriting, that is 30.81% and has a mass of 17. So it's telling us to calculate the atomic mass. So just to give you an idea of what atomic mass is fractional abundance multiplied by the mass of the isotope. So we have fractional abundance and we have mass of the isotope. So to calculate the atomic mass of this element, you're going to multiply these two numbers together, and then you're going to add it up together. But first, you want to make sure that your fractional abundance is in decimal format. And so you need to divide each of these percentages by 100, which is simply just moving this decimal point over 2 for each of them. So then what your problem becomes is simply 0.5024 times 16 plus 0.1895 times 14 plus 0.3081 times 17 equals your atomic mass. And so when I plug that into a calculator, and make sure that you use these parentheses on your calculator. I find that a lot of students know how to do the problems, but they input it into the calculator incorrectly. And so then it says to three significant figures. And so then you're going to get 15.9. And that is your answer. Now on the exam, because it's multiple choice, significant figures aren't going to matter as much, but you should still understand how to do significant figures. And so you can watch a quick YouTube video, but the idea is if the question doesn't tell you how many significant figures it wants, you're going to look at all the numbers that's in your problem, and you're going to go with the lowest amount of sig figs across all the numbers. So that's how you do question 4. Question number 5, which of the following chemical formulas are empirical formulas? Select all that apply. So in order to do this problem, you're going to need to understand what empirical formulas mean. An easy way to understand and remember empirical formula is think about this word empirical. If you've taken math classes, you've heard this word many, many times. And so my mind connects it with math. And in math, we always like to simplify things. So that's what empirical formula is. It's the formula in its simplest format. So for example, let's look at CO2. You have 1 carbon and 2 oxygen. So you can think about it, even though we do not write ones normally, you can think about it like this. Now, you have 1 and 2. Can we divide these numbers by something to simplify it further? The simple answer is no. 1 and 2 are in their simplest format. And so this would be an empirical formula. MgClO4 2. Now, what I find students doing is when they have a polyatomic ion, they forget that it's a polyatomic ion and they break it up. And so they try to distribute this 2. So you have 2 and you have 8, and then you have 1. Do not do that. This perchlorate here is one whole unit together, and we have 2 of them. So essentially what you're looking at is you're looking at Mg1, then you're looking at ClO4 2. So again, similar situation to what we had above. We have 1 and 2. And again, that cannot be divided any further. And so we know that Mg, or magnesium perchlorate, is in fact in empirical format. Now let's take a look at a more complex formula. And it may trip you up, but again, if it's a polyatomic ion, make sure you group it together. If it's on the periodic table, group it together. So usually if you see capital letters, that's when you know you're moving on to a different element. So we have Pb, we have H, we have A and S, which is together, and then we have oxygen, which is 4. So here you're looking at 1 of Pb, 1 of H, 1 of AS, and 4 of O. Again, we have 1, 1, 1, and 4. There's nothing that we can divide all those numbers by to get a simpler format. So again, this is also an empirical format. Now, we have C2H6. Is there a number that can be divided by both 2 and 6 that can simplify these numbers? Well, 2 can be divided by 2 to give you 1, and 6 can be divided by 2 to give you 3. So really the simplest format should be 1 and 3. So we know that C2H6 is not an empirical formula. Another way to think about this, if you have all even numbers, it's most likely not an empirical formula because then it can all be divisible by 2. Now let's look at our last one. We have aluminum and we have sulfate. Again, this is a polyatomic ion. Do not separate it. It is one whole, and there's 3 of them. So we have 2 and we have 3. There's nothing that can be divided by 2 and 3 to give you a more simpler number. So again, this would be considered an empirical format. This is another common question on an exam. So again, understand what empirical format means. If you can take the numbers and divide them to make them simpler, then you know that it's not an empirical formula. You're going to have questions like this, but then you're also going to have questions where it shows you a formula that's not in empirical format. It's going to ask you to put it into empirical format. And so that's simply just taking the 2 numbers, finding a common divisible, and dividing both those numbers by that number. And that is how you do this question. So question number 6. Here you're being asked to classify nitrogen and lithium as either a nonmetal, a metalloid, or a metal. Now, it's very important that you print out a periodic table and you begin to write on it so that you can begin to understand how to look at a periodic table in the most effective way. So if you're looking at the left side of the periodic table, that is all of our metals. And as you move toward the right, the metallic characteristic of the elements are decreasing because then you're going to get to your metalloids and then you're going to get to your non-metals. And so let's look at nitrogen. Where is nitrogen on the periodic table? It's all the way to the right. So if it's all the way to the right, we know that it has to be a non-metal. So if it's all the way to the right, if it's all the way in that direction, we know it's a non-metal. But if it's all the way to the left, we know that's a metal. And then somewhere in between here, we have our metalloids. And so where's lithium? As you go through this course, you're going to get a lot better at recognizing element names and their chemical symbols. Most times it's very straightforward and they use the first two letters, but that's not always the case. But with lithium, it is. So Li. So if you look at your periodic table, try to find where lithium is located. And you'll find that it's in group 1. Okay? So if it's in group 1, that tells us it's all the way on the left side. And if we look at our chart here, we know that if it's all the way on the left side, then it must be classified as a what? Metal. And that is how you do this question. Now, the final question on the homework is question 7. Which of the following species has 17 protons and 18 electrons? So the first thing I want you guys to see here is that we have an imbalance of protons, which are positively charged, and electrons, which are negatively charged. Okay, so we know that whatever element that we select, it must have a charge. And so any of the answer choices that are neutral, you can quickly eliminate them. Now, I want to ask you a question. Do we have more protons or more electrons here? We have more electrons, which means the charge on our chemical symbol, so whatever chemical symbol we end up having, I'll just denote that X, it's going to have a negative charge. But how large will that negative charge be? Will it be -1, -2, -3? And the way to figure that out is ask yourself, what is the deviation between our protons and electrons? Just one. So we know we have a -1 charge. Now, you can omit that 1 and you can write it simply the chemical symbol with a negative charge like that. So how do we figure out which element we're talking about here? Again, atomic number equals protons. But the atomic number also tells you the chemical symbol. So if you look at the periodic table, you need to look for the number 17. And it's going to be the large number above the element. And if we look at the periodic table, we see that's chlorine. So chlorine has 17 protons. And we know that it has 18 electrons. A neutral element of chlorine would have 17 electrons. But because we have 18 electrons, it's not just chlorine by itself, but it's chlorine with a minus charge. And so that is the final answer. So again, my goal with these homeworks is to break it down and to explain my thought process and how I approach these questions. If I am your peer leader, please come up to me if you have any additional questions on homework number 1. And let me know in the comment section below or reach out to me if you need any additional help. Thank you.